Okay, so very first thing we're going to talk about, it's the multiplicative identity matrix. Okay, and depending on the sizes of these, they actually kind of do a couple of different things here. If it's a 2 by 2 matrix, looks like that. So they'll kind of show it like I2 and I3. That way we know it's a 2 by 2 matrix. If it's an I3, it's a 3 by 3 matrix. And then basically you put ones on the diagonals and then you put zeros everywhere else. Okay. And now we're not going to worry about an I4 matrix. If we did, it would just be that. So again, if we want an I5, we just keep adding more, to the corner. So basically you've got ones on the diagonal and you can just extend that out for as many, whatever size matrix you want to go with if you make it a square matrix for this thing. Okay, now where that ties in with what we're doing, and we're basically going to get some practice for the multiplying yesterday, is this, that if you multiply, say we've got two matrices that we're looking at, A and B, this thing, if you multiply A times B or B times A, and that equals, and then we're just going to say I for now, that I is the identity matrix. So back up here, probably should have done this. So it's just I. And again, it will change depending on what size it is that we're looking at. But if you take either one of these two matrices and you multiply them together, and you get the identity matrix, then you can say that matrix B is the multiplicative, kind of fun word to say, the multiplicative inverse of A. So really we're looking at A times B, but we're going to say you could still reverse it and do B times A. But if you multiply these two matrices together, if it's a 2 by 2 matrix and you get this, or if it's a 3 by 3 matrix and you get this, if you multiply them together and you get the result to look like that, they're inverses of each other. And how they're going to show that, if we got something that's inverse, they show an A to the negative 1 power. So with matrices, if you ever see this negative 1, they're talking about inverses. They're going through this. Okay, so let's give you two matrices here. One. Okay, so if A is 1154, B is negative 415, negative 1. Let's ask the question, are A and B inverses? Okay, and again, if they give you two matrices and ask them inverses, all we're doing is we're doing multiplication, just like we were doing yesterday, just like we did on the bell ringer. So we're going to take first row, multiply it by the first column, and we're going to put that answer down here. So it's 1 times negative 4, which is negative 4. And when you're doing these, don't try to do too much of it in your head. Go ahead and write some stuff out, even if it's over on the side somewhere. Just write it down, because if you try to do too much, sometimes you lose it. We've got 1 times negative 4 is negative 4. 1 times 5 is 5. we've got -4 plus 5, which would be 5 minus 4, which is just 1. Okay. And then we're going to do 1, 1 times this column. So we've got 1 times 1 for 1. We got 1 times -1 is -1. 1 minus 1 is 0. Okay. So far, so good. Okay. And then second row. Again, if we're going to multiply times this column, that answer is going to go down, but we're just going to put it down here. So we've got 5 times -4, which is -20. And then 4 times 5 is +20. So -20 plus 20 is 0. Okay, and then one last one to check. We've got 5 times 1 for 5. 4 times -1 is -4. 5 minus 4 is 1. Okay, and again, as long as we got zeros on the diagonal, or sorry, ones on the diagonal going this way and zeros everywhere else, then they are inverses. So in that case, yes, those two things would be inverses. Okay, now let's show you one where they're not going to be inverses, so we can see the difference of the two. Okay, so can't see. So for matrix A, let's go with 3, 2, 5, 4. And for matrix B, let's go with -2, 1, 4, -3. Okay, so first thing is, again, we're going to go here, multiply these two numbers by these two numbers, and we'll put the answer underneath it here. So we've got 3 times -2 for -6. We've got 2 times 4 is 8. -6 plus 8 is 2. Okay, and again, in that case, the very first number in the corner has got to be 1. So if that thing is not 1, you don't have to go any farther. You just say, no, it's not. So if this number is not a 1 and this number is not a 0, so if we'd done this and this had been a 1 and this came out to be like 2 or 3 or 5 or 7, some other number, if it's not 1, 0 to start off with, then if those numbers don't match up, you just stop and say, nope, it's not going to be there. Okay, so again, just keep checking your multiplications, seeing what you get from those. And again, you just take it one number at a time. If this is 1, then you go to the next one. If this is 0, then you go to the next one, and then need 0, 1. And at any point in time, if it doesn't match up with the numbers, you don't have to keep checking it. If the first number is off, then just stop, and that's as far as you've got to go with it. Okay, so there, and again, whether it's a 2 by 2 or a 3 by 3, it's still that same process of just multiplying your rows and your columns to get the numbers that you're looking for. The next thing we're going to look at, new definition for this one here, is a determinant. Okay, if you don't know this or not, math people get tired of writing long words. So for determinant, they're just going to say short. We're just going to call it DET. Okay, and for determinant, we're going to take you back to your probably middle school days, 6th, 7th grade. Okay, so very first thing we're going to do, show you one without numbers, just so we got a general sense of it. And then we'll show you one or two with some numbers because we got it there. So leave a little bit of room because we're actually going to work around this one to get the numbers for this one. So if A is that, if that's our matrix, if it's A, B, C, D, where we've got 4 numbers. So if they ask you to find the determinant of A, all you do is take whatever matrix they give to you, and we're going to take you back to your cross product days. So we're going to multiply A times D, and then B times C, and all you're going to do is you're going to subtract those two numbers. Okay, now, and the catch is you have to do your cross. I know most time we do cross products down. This one, you have to go up on your cross products. If you go down, you get the order reverse, which means the number comes out to be wrong for that part. So make sure when you do your cross products that you go up to get your cross products for determinant. Okay, let's give you some with some numbers. So if it's 2, 5, negative 4, 8. Okay, so they give you this one, ask you to find a determinant, and again, it's just cross products in the up direction. So it's 2 times 8 for 16 minus negative 4 times 5 is negative 20. So if you do 16 minus negative 20, that's really 16 plus 20, and that's 36. Okay. Okay, so for this one, let me show you one more. We're going to go to a 3 by 3 matrix and show you how that would be and what it's going to be for that part. I don't know that I'll make you do one of these on the test. This may be a bonus question kind of thing. So we'll see what we can do with it here. All right, so for 3 by, and again, we can do more examples, but it's pretty straightforward. Just multiply, multiply, subtract those two numbers. Whatever number you get, that's what your determinant's going to be. All right, 3 by 3 gets a little tougher because it's a little bit bigger. We're still going to do cross products, but when we go back and do this one, it doesn't quite line up. So we're going to show you what we're going to do. So we're going to go A, B, C, D, E, F, and then G, H, and then I. Not that you can see that because I didn't bring it down. Okay. So if we've got a 3 by 3 determinant, if we've got a 3 by 3 matrix, we've still got to do cross products, but we got to do it basically with all these numbers that's here. So if we get ready to do cross products, there's only one that we can do here and one that we can do here. So if we did that, just show you real quick. We've got A, E, and I. We've got G, E, and C that we've. It's not working. Can't see. I was hoping it would be so you could do this and you'd see the letters that left. Okay, that kind of works. If we do cross products like that, we didn't use B or D or F or H. So if you're going to use the determinants in this case, you got to use every single letter to get everything involved for this thing. So what we're going to do is, again, leave a little bit of room for this one above it because we're going to work above it again. So if we're going to do the determinant of that matrix, We're going to take that original matrix we've got, and basically we're going to take the first two columns we've got here and then rewrite them on the outside. Okay, and that way we can actually now go back and do our cross products. We can do A times E times I. And we're going to add that to B, F, and G. Anybody ever watch that movie Big Friendly Giant? Just seeing the initials BFG made me think of Big Friendly Giant. I think there was a movie about that way back when. And do one more here. We got C, D, and H. Okay, and then we're still going to do minus. But then we're going to go this way. We're going to do GEC. Then we're going to do H, F, and A. Oh, didn't write that one big enough. And then one more time, we'll do IDB. Okay, so it's everything going this way, then minus everything going that way. And that way we've used everything. And you may be saying, well, we didn't use the D that was here. No, but we used D here. We didn't use this E, but then we wound up using that one here. So every letter wound up getting used at some point in time as we went through this thing. And that's basically what we got to do. We got to kind of, recreate it, if you want to call it that. Okay. And again, max these in the homework. You'll only get one of these in the homework, guaranteed. Won't give you two, because if you can do one, you could do more than that. And again, it's just the same kind of process going through this. So let me give you one example, give you one other little thing, and then we'll wrap this thing up for today. We'll pause right there for just a minute. Y'all ready for one with numbers?
No.
No? Okay. Well, we're going to get it anyway. Sorry. Okay. All right. So we're going to find the determinant of, let's go 103, 246, and then 5, -1, 3. Okay, so again, very first thing we're going to do once they give us this one is you would write it down, obviously, and then go back and write down the first two columns out beside it. Okay, and then it's not hard. Just make sure you keep up with your multiplication you go through. It's 4 times 3 times 1, which is 12. 5 times 6 is 30. Zeros are nice because if we do 30 times 0, that's still just 0. And then we've got -1 times 2 is -2 times 3 is -6. Okay. And then we're going to go minus, and then we're going to go in this direction. 5 times 4 is 20. 20 times 3 is 60. 6 times -1 is -6. Times 1 is still -6. And then 3 times 2 times 0 is nice because that's just a 0. Okay, so we've got 12 plus 0, which is 12. 12 minus 6 is 6. minus 60 minus 6 is 54. So we've got 6 minus 54. So that's a negative 48. So the determinant of that matrix is negative 48. And again, when we're doing determinant, it's just a number that we're going to get for this part of it. Okay, and then the last thing, one last statement, one last sentence here. If the determinant equals 0, then the matrix does not have an inverse.